keeping the base of segment of a triangle unchanged and its opposite vertex sliding on a line parallel to the base, the area of the triangle will remain the same. This operation has a nickname, curtain sliding. It can be used to calculate the areas of triangles and polygons. The first example, ABCD is a square with side length 2. Extend AB and DC to points E and F to form a rectangle BCEF. BC and DE has an intersection G. Question: what is the area of triangle DFG? The triangle is partitioned into two smaller triangles DCG and FCG. The sum of their areas will be the answer. Sliding triangle FCG at point F to obtain a new triangle ECG with the same area as FCG. These two triangles form a new triangle DCE, which should have the same area with the one we are trying to calculate. Curtain sliding the triangle for point E to reach another triangle BCD, which is exactly one half of the 2 by 2 square ABCD, and therefore its area is 2. The job is done. Another example, ABCD is a rectangle with area 28. Point E and F are on BC and CD so that BE has a length 1 and DF equals 2. Question: what is the area of triangle AEF? The area of the triangle can be calculated indirectly. The area of the rectangle ABCD subtract the remaining three triangles ADF, CEF, and ABE. These three triangles use boundaries of the rectangle ABCD. They are easy to perform curtain sliding. The rectangle ABCD is further partitioned into four smaller rectangles using EG and FH. The intersection is I. The rectangle AGKH at the top left corner, 1 by 2, has an area 2. Triangle ADF is partitioned into two triangles by segment FG. Now we are ready for curtain sliding. For triangle FAG, sliding F to I to obtain a new triangle IAG with the same area. Sliding vertex G of the other blue triangle GDF horizontally to reach another triangle EDF. Of course, the area is still the same. Finally, moving A down all the way to point D, the green triangle ABE becomes DBE. Now look, after these operations, three triangles becomes 2. First, the smaller one, AGI, is one half of the 1 by 2 rectangle AGIH. And the other triangle is BCD. It is one half of the larger rectangle ABCD, which has an area 28. Therefore, the area of triangle AEF is 28 minus 1 plus 14, which is 13. That is the final answer. Thank you for watching.